Hi everybody, I'm going to try to explain to you about graphing linear inequalities in two variables. Let me start with an example, a sort of pseudo real world example of why you might want to use linear equation or linear inequalities in two variables. Okay, let's say t-shirts cost $10 each and caps cost $8 each, and you have $40 in your possession. What can you afford to buy with that $40? Well, we can set this up by letting X stand for the number of t-shirts you buy, and Y stands for the number of caps you buy. So how much that's going to cost you is $10 for each of those X t-shirts you buy, plus $8 for each of those Y number of caps you buy. And that has to come out to be less than or equal to $40. It can't be more than $40 because that's all you have to spend. So there's an example of an inequality in two variables, x and y. Some of the solutions, some of the pairs of numbers that make that true include 4, 0, because 10 times 4 plus 8 times 0 is 40. 0, 5, because 10 times 0 plus 8 times 5 is 40. 1, 1, because 10 times 1 plus 8 times 1 is 18, and that's less than 40. 2, 2 works. 20 plus 16 is less than 40. Negative 1, 6 works, because 10 times negative 1 plus 8 times 6, that would be negative 10 plus 48, that would be 38, and that's less than 40. 1.53 works. And then some examples of pairs of numbers that don't work would be 5, 0. 10 times 5 plus 8 times 0 would be 50, and that's not less than or equal to 40. 2, 3. 10 times 2 plus 8 times 3 would be 20 plus 24. That's 44. That's not less than or equal to 40. And of course, if you stick in 100 for x and 100 for y, you get something that's definitely not less than or equal to 40. So that means you could afford to buy 4 shirts and no caps. Or you could buy 0 shirts and 5 caps. You could buy 1 shirt and 1 cap. You'd have some money left over then, but you could afford to do that. You could buy 2 shirts and 2 caps. You could buy -1 shirts and 6 caps, which might or might not make sense. Maybe that means you sell 1 shirt and buy 6 caps. You could buy 1.5 shirts and 3 caps. Well, maybe you can't really buy 1.5 shirts, but at least that does work in the inequality. It works mathematically. But you cannot afford to buy 5 shirts and 0 caps. That would cost you $50, which is more than what you have. You could not afford to buy 2 shirts and 3 caps. You could not afford to buy 100 shirts and 100 caps. So we can show what all the possibilities are by making a graph of this inequality. And here's what that looks like. So the blue line here, all the points on this blue line are where 10x plus 8y comes out to be exactly equal to 40. And then all the points in this shaded region here have x and y coordinates that make 10x plus 8y be less than 40. So all of the solutions, like 4, 0, 0, 5, 1, 1, 2, 2, -1, 6, 1.53, they're all part of the shaded region. They're either on the boundary line or somewhere in the middle of that shaded region. And all the pairs of numbers that don't work, like 5, 0, or 2, 3, or 100, 100, are on the other side of the line in the non-shaded region. So if you wanted to know, can I afford to buy a certain number of t-shirts and caps, you can just find that point and see whether or not it's in the shaded region. Can I afford to buy 1 shirt and 3 caps? Well, there's the point 1, 3. It is part of the shaded region, so yes. Can I afford to buy 3 shirts and 2 caps. Well, the point 3, 2 is not in the shaded region, so no. So there's an example, and now we're going to talk about how we go from this to this, how we go from the inequality written in symbols to the graph. It's going to be a two-step process. Step 1 where we draw the line, and then step 2 where we shade everything on one side or the other of that line. Since we're going to be drawing lines, we have to remember how to graph linear equations. So let me remind you how that works. If you can find 2 or more pairs of numbers that satisfy a linear equation and plot the points that correspond to those pairs of numbers, then you draw the line through those points, and that's the graph of the equation. One specific method that's often easy to use is the intercepts method, where the points that you find and plot are the x-intercept and the y-intercept. The x-intercept is going to have 0 for its y-coordinate, and it's going to be on the x-axis. And the y-intercept is going to have 0 for its x-coordinate. It's going to be on the y-axis. And those are your 2 points, and then you draw the line through them. So, for example, let's say we want to graph the equation 3x minus 7y equals 21 using that intercepts method. First of all, if x is 0 in this equation, what's y? If we put 0 in for x, that's easy because 3 times 0 would just be 0, and then all we have over here is negative 7y equals 21. Then divide both sides by negative 7, and you get y equals 3. So that gives us the point 0, negative 3, where x is 0 and y is negative 3. Now, if y is 0, what's x? If we put 0 in for y, 3x minus 7 times 0 equals 21. Again, this would just be 0, so we just have 3x equals 21. Divide both sides by 3, you get x equals 7. So the point where x is 7 and y is 0 would be here on the x-axis. And now that we have these 2 points, we can just draw the line through them, and that line is the graph of that equation. One other method that's sometimes easy, especially if your equation is set up in slope-intercept form, is to use the slope and the y-intercept to show you how to graph the equation. So the way this method works is get the equation into the form y equals mx plus b if it isn't already. This is particularly useful if it is already in that form, because then you can just go ahead and see the number in front of the x is the slope, and the constant term is the y-intercept, and you can use those to draw the equation. So for example, y equals negative 3x plus 5. That is in that y equals mx plus b format. The part of m, the number in front of the x, is being played by negative 3, and the part of b, the constant term added onto the end, is being played by 5. So we'll start with that. The y-intercept is 5, and that means that the graph of this equation is a line that crosses the y-axis at 5, at the point 0, 5 on the y-axis. So take that as your starting point. Then the slope is negative 3. If you want to think of that as a fraction, so it's rise over run, you can think of it as negative 3 just over 1. So rise over run is negative 3 over 1. So starting at the y-intercept point that we took as our starting point, rise negative 3 and run 1. That means go down 3 spaces and over 1 space. If you want, you can do it again, down 3 and over 1, down 3 and over 1. And so that shows you which direction the line is going, and then you can just draw the line through those points. Some special cases to watch out for: if you have an equation that only has an x in it, no y, but you are thinking in two-dimensional terms. An equation like x equals 6. The graph is a vertical line. In this example, it's this red line here, because all the points on this line have their x coordinate equal to 6. X could be 6 and y could be 0. X could be 6 and y could be 1. X could be 6 and y could be 4, and so on. The other special case to watch out for is when you have just y. Y equals some particular number. And the graph of an equation like that is going to be a horizontal line. So for example, the equation y equals -2 has a graph that just goes right straight across like this. And all the points on this line have their y coordinate equal to -2. You got 0, -2, you got 1, -2, you got 5, -2, all the way across. In the next video, I'll go into some examples of graphing inequalities, but just to give you a preview, that's going to be a two-step process. Step 1 is where we draw the boundary line, and that's going to be the line that would be the graph of the equation if you had an equal sign in there instead of one of those inequality signs. But when you draw that line, you either make it a solid line if the points on the line are supposed to be included, or you make it a dotted line, or a dashed or a broken line, if you're not including the points on the line because it just says less than or just greater than. And then, so in the example we were looking at earlier, the boundary line was the line where 10x plus 8y was equal to 40. And I do want it to be a solid line because we are including the points where it's equal, where 10x plus 8y is equal to 40. Notice it says less than or equal to. Then step 2 is to shade everything on one side of the line. But you just have to figure out which side of the line to shade. Here's how you tell. The test point method involves picking any point that's not on the line and plugging its coordinates into the inequality. If the result is true, then shade the side that includes that point, and if not, shade the other side that doesn't include that point. There's also an alternative method that you could use if your inequality is solved for y. I'll talk about that in the next video. But for the test point method, in the example from earlier, if I test the point 0, 0, which is often a really easy one to work with, so that's a good one to use here. If I plug in 0 for x and 0 for y, then it says 10 times 0 plus 8 times 0 is less than or equal to 40. Well, 10 times 0 plus 8 times 0 is just a big old 0, and that is indeed less than or equal to 40. So that is true. So when we decide which side of this line we want to be on the side that includes the point 0, 0 that we just tested. That's this point over here, so we shade everything on this side of the line. Okay, I'll be back in another video to show you some more examples. We'll work through some more examples of this.